So this time we want to know what happens when what's left doesn't factor. So after you take out the original factor they were telling you about, what if that quadratic isn't factorable? Then what do we do? Well, that means you have to use some other technique that we learned in the last chapter. So once it's down to a quadratic, if it's not factorable, then you have to use one of our other techniques like completing the square, quadratic formula, in which most of you are probably going to go with quadratic formula, unless it's something really simple, and then you might decide to use completing the square. All right, so on this first one, f of x equals x cubed plus x squared minus 7x minus 3. And there's a little typo right here. It should say x plus 3 is a factor of f of x. So if that's the case, then negative 3 is supposed to be a root. So we're going to do what we did on the previous page. We're going to use that root to factor down the cubic to our quadratic. So negative 3 on the outside. And then our coefficients on the inside. Hopefully we get a 0 there. So negative 3, negative 2, 6, negative 1, and 3. So there's my 0. So if I write this back in with all its exponents and variables, this is now x squared minus 2x minus 1. Okay, and I was given the x plus 3. All right. Unfortunately, if we try to factor this, factors of negative 1 that add to make negative 2 are not possible. Okay, so this is a no. This doesn't factor. But I still need to solve that quadratic somehow. And so I can either use completing the square or quadratic formula to find what two roots are hiding in here, which means they're probably not nice numbers. They could be some sort of fractions, decimals, or even radicals that can't be simplified. All right, so since this one's pretty easy numbers, I'm just going to do completing the square on this one, kind of run you through it and remind you how it works. So x squared minus 2x minus 1 equals 0. That is not the c we want, so we're going to move it. Add it to the other side. Then we're going to put in our c. We're going to take b, divide it in half, and square it. So that's going to be 1 squared, which is 1. Add that to both sides. Write this in factored form. X minus 1 squared equals 2. Then we have to get rid of the square, so we square root both sides, and don't forget our plus or minus. So x minus 1 equals plus or minus root 2. Then we just need to add the 1 to the other side. So we're going to get 1 plus or minus 1 root 2 for our other factors. And yes, those are exactly the same thing you get if you were to plug it into the quadratic formula. All right, so list all of our roots. Well, this was as far as we could factor it, so this was our factored form, because this one didn't factor any further. But listing all the roots, I know I've got the negative 3 from up here, and then I've got 1 plus the square root of 2, and 1 minus the square root of 2. So there are my 3 roots. Okay. And you could leave this as 1 plus or minus the square root of 2. That is fine. All right, so let's look at a couple more examples down here. Okay, so for this one, I'm told x plus 4 is a factor. So that means my root is negative 4. So let's take that out. Okay, do my synthetic division process. Oops. Going to add, I tried to multiply. So negative 6. This will be a positive 24. That adds to make 10. So there's my negative 40 and my remainder of 0. Alright, so my factored form, x squared minus 6x plus 10 times the x plus 4, because there are no factors of 10 that add to make negative 6. So it's definitely not factorable. So this is all I can do when it comes to factoring it. That's question 1. Then I'm going to have to find all those roots. This one's easy. I know that's negative 4. This one I'm going to have to either quadratic formula or complete the square. If you want to throw down the quadratic formula this time, we can. So it'll be 6 plus or minus the square root of negative 6 squared, which is going to give me 36, minus 4 times 1 times 10, all over 2 times 1. So in here I'm going to get 36 minus 40, which 36 minus 40 is going to leave me with a negative 4 inside. So 6 plus or minus the square root of negative 4 over 2. We can clean that up. Square root of negative 4 is 2i. So 6 plus or minus 2i over 2, which cleans up to 3 plus or minus I when I reduce everything by 2. So I do get my 3 parts. I've got 3 plus I, 3 minus I, and then the negative 4 from the given in the original problem. So those are the roots which answer the second part. Okay. All right, one more like that. This time we are given x minus 1, so 1's going on the outside. Write our numbers across. Bring them down. All right, so there's my remainder of 0 again. Okay, I'm left with 9x squared plus 6x minus 7 after I do the division. Check for factors. A times c is negative 63. And there are no factors of negative 63 that will add to make 6, so it's not factorable. Okay, so that's as far as I can factor it. So that's the first part, and then it wants me again to find the roots. So I know this one's going to give me 1, and then I can use quadratic formula, probably best bet on this one because of the 9, to find the 2 solutions there. So if I do that real quick, we get negative 6 plus or minus the square root of 6 squared minus 4 times 9 times negative 7 over 2 times 9. So negative 6 plus or minus the square root. Clean all this up. 36 plus all of this is going to give you 288 over 18. Doing a little work. 288 is 144 and 2. So that's a perfect square in there. So it can be negative 6 plus or minus 12 root 2 all over 18. And then you can reduce 6, 12, and 18 all by the 6, which will leave you with negative 1 plus or minus 2 root 2 all over 3. And then don't forget the 1 that you had as a root from way up there. Okay, so for your roots, you end up with 1, negative 1 plus 2 root 2 over 3, and negative 1 minus 2 root 2 over 3. So if we answer that last question, what are the roots? So in this example, we got 3 roots. One of them was a nice rational number. 2 of them were irrational. And in this example over here, we did get the 3 roots. We got 1 real root, and then 2 of them ended up being imaginary.